Panzer commander's training had been thorough. He could identify every Allied tank by silhouette at 2,000 meters. The Sherman's vertical hull, the Churchill's awkward proportions, the Cromwell's low profile. But the vehicle emerging through the Norman dust didn't match his recognition charts. It had the Sherman's general shape, but lower. The hull was smooth, cast as a single piece, not the welded construction of American factories. The turret was compact, different from the standard Sherman configuration. His intelligence briefings had mentioned Canadian training tanks, vehicles never intended for frontline service. He adjusted his range estimation, preparing to engage what he assumed was an obsolete target. He never got the shot. The vehicle's turret was gone. Where a gun should have been, there was only open space. And from that space, a full infantry section poured out, already firing, already moving toward his position with a speed that foot soldiers couldn't match. This was August 1944. The Canadians were introducing a weapon the Germans hadn't anticipated, not because of its firepower, but because of what it wasn't trying to be. This was the ram tank in its final evolution, the gun tank that never fought as a gun tank, the supposed failure that became the blueprint for every armored personnel carrier in modern warfare. The story of the ram is the story of Canadian innovation under impossible constraints. In 1940, Canada had exactly 0 factories capable of producing tanks. 18 months later, they were manufacturing a medium tank that, in several critical aspects, was superior to anything the Americans or British were fielding. And when that tank couldn't compete with German armor evolution, Canadian tactical thinking transformed it into something more valuable than another gun on the battlefield. This is about more than one vehicle. It's about how industrial necessity forced innovation and how tactical flexibility turned apparent obsolescence into enduring influence. Before we examine exactly how Canada built this machine and why it mattered more as a personnel carrier than it ever could have as a battle tank, take a moment to subscribe to the channel and let us know in the comments where you're watching from. What city and country are you in? Now, let's go back to June 1940, when Canada faced a crisis that would reshape its entire industrial capacity. The fall of France changed everything for Canada's military calculus. Britain was desperate for tanks. The United States hadn't yet entered the war and couldn't supply the Commonwealth. Canada's entire armored force consisted of outdated vehicles, many of them relics from the previous war. The problem was fundamental. Canada had automotive factories. It had railcar manufacturers. It had the industrial capacity to produce complex machinery. But tank production required specialized knowledge that didn't exist in Canadian engineering firms. The metallurgy for armor plate, the precision machining for turret rings, the transmission systems for tracked vehicles. Every component represented a technical challenge that Canadian industry had never confronted. The solution emerged from an unlikely source. Montreal Locomotive Works had experience with heavy machinery and complex castings for railway equipment. If they could cast locomotive components, perhaps they could cast tank hulls. The British provided technical specifications for their cruiser tanks. The Americans offered access to the M3 medium tank design they were developing. Canadian engineers studied both and recognized an opportunity. They would use the M3's proven chassis and running gear, eliminating years of development time. But they would design their own hull and turret, incorporating techniques that neither the Americans nor British were yet using at scale. The timeline was impossible. Prototype to production in less than a year. But the alternative was sending Canadian soldiers into battle with inadequate armor, and that wasn't acceptable. The ram that emerged from Montreal Locomotive Works in late 1941 was a hybrid vehicle, but calling it simply a modified M3, Lee misses what made it significant. The Canadians had taken American mechanical reliability and imposed their own engineering philosophy on top of it. The foundation was sound. The Wright Continental R975 radial engine produced 400 horsepower, the same power plant used in American medium tanks. The vertical volute spring suspension, also borrowed from the M3, provided adequate cross-country mobility. The transmission was a 5-speed manual system, primitive by later standards but reliable enough for the era. At 29 tons combat loaded, the Ram fell into the standard medium tank weight class, but the hull told a different story. Where the M3 Lee used a riveted construction with multiple armor plates bolted together, the Ram employed a one-piece cast hull. This wasn't merely an aesthetic choice. Riveted armor had a fatal flaw that tankers called spalling. When a shell struck riveted plate, even without penetrating, the impact could shear rivets on the interior, sending them through the crew compartment like shrapnel. Men died from their own armor. The cast hull eliminated that vulnerability entirely. The technique required sophisticated foundry work and precise metallurgical control, capabilities that Montreal Locomotive Works developed specifically for this project. The Americans wouldn't adopt cast hull construction for the Sherman until mid-production runs in 1943. The Canadians had it operational in 1941. The armor itself was adequate for the period. 63 millimeters on the front hull, sloped at an angle that provided effective protection equivalent to 80 millimeters against flat trajectory fire. Side armor was 38 millimeters, sufficient against most anti-tank rifles and smaller caliber weapons. The turret front was 76 millimeters, again competitive with contemporary designs. Where the Ram stumbled was in its armament evolution and the limitation that would ultimately define its combat role. The initial production model, the Ram Mark I, mounted a 2-pounder gun. This was the standard British cruiser tank armament in 1941, adequate against German Panzer IIIs and early Panzer IVs. But tank warfare was evolving faster than production schedules. By 1942, the 2-pounder was obsolete. The Ram Mark II addressed this with a 6-pounder gun, the 57mm weapon that gave respectable anti-tank performance. But here, the design encountered its critical constraint. The turret ring, the circular opening in the hull where the turret sits, measured only 60 inches in diameter. This dimension was inherited from the M3 Lee chassis, and it couldn't be changed without redesigning the entire hull. 60 inches was sufficient for the 6-pounder. It was not sufficient for the 75mm gun that was rapidly becoming the Allied standard. The Sherman, with its 69-inch turret ring, could mount the larger weapon. The Ram could not. This single dimension, determined by decisions made during the rushed development process, meant the Ram would never be able to match the firepower of the tank it was based on. The comparison with the Sherman is instructive. Both used the same engine. Both had similar mobility. The Ram's cast hull was arguably superior in construction. But the Sherman could upgrade to the gun the battlefield demanded, and the Ram couldn't. By 1943, when Canadian armored units were preparing for the invasion of Europe, the choice was clear. They would use Shermans, supplied through Lend-Lease, because the Sherman could fight the Panther and the later Panzer IV variants. The Ram couldn't. 570 Ram tanks were produced between 1941 and 1943. Not one fired a shot in anger. As a gun tank, by conventional metrics, this was a failed program. 2 years of industrial effort, substantial financial investment, and a capable design that arrived just as the battlefield moved beyond its capabilities. But Canadian tactical thinking was about to turn that failure into innovation. The problem that created the Kangaroo's purpose was written in blood across the Normandy hedgerows. Infantry, advancing on foot, died. The German defensive doctrine was built around interlocking fields of machine gun fire, particularly the MG-42, a weapon that fired 1,200 rounds per minute. Crossing open ground toward prepared positions meant casualties, that no amount of artillery preparation could prevent entirely. The Allied solution had been to use infantry support tanks, heavily armored vehicles that could suppress defensive positions while foot soldiers followed. But the infantry still had to walk. They were still exposed to shell fragments, to machine gun fire that swept over positions the tanks couldn't directly engage, to the simple physics of men on foot trying to close distance against enemies in fortified positions. Lieutenant General Guy Simonds, commanding the 2nd Canadian Corps, recognized this as an engineering problem with a mechanical solution. He had tanks that couldn't fight as gun tanks. He had infantry that needed protection. The connection was obvious once you stopped thinking about the Ram as a failed battle tank and started thinking about it as a mobile armored box. The conversion was mechanically simple. Remove the turret, remove the main armament, remove everything related to the gun system. What remained was a fully tracked, fully armored vehicle with space for 10 to 12 infantrymen and their equipment. The armor that had been inadequate against German anti-tank guns was more than sufficient against machine gun fire and shell fragments. The mobility that had been merely acceptable for a gun tank was excellent for an infantry carrier. Simonds ordered the conversion of 72 Ram tanks in late July 1944. The work was done by Canadian engineers in forward workshops, not in factories. This was battlefield improvisation at an industrial scale. The converted vehicles were designated Kangaroos, a name that emphasized their role as carriers rather than combatants. The tactical doctrine was equally straightforward. Infantry would mount in assembly areas behind the front line. The Kangaroos would advance in formation with gun tanks providing fire support. At a predetermined point, typically 200 to 300 meters from the objective, the Kangaroos would halt and the infantry would dismount, already at the enemy position, rather than having spent 10 minutes crossing open ground under fire. Operation Totalize provided the first test. The attack began on the night of August 7, 1944, targeting German positions south of Caen. The Canadian and British infantry assigned to the assault had been briefed on the new procedure, but many remained skeptical. Riding into battle inside what amounted to mobile steel boxes contradicted every instinct about dispersal and avoiding concentrated targets. The German defenders had prepared for a conventional assault. Their machine gun positions were sited to create killing zones in the approaches. Their mortar teams had pre-registered defensive fire missions on likely assembly areas and approach routes. Their anti-tank guns were positioned to engage supporting armor. What they encountered instead was a formation of armored vehicles that didn't stop to fight, that ignored their fire, and that delivered formed infantry sections directly onto their positions. The casualty differential was immediate and measurable. In previous infantry assaults across similar terrain, Canadian units had routinely suffered 30 to 40% casualties crossing the final approach to German positions. In Totalize, using the Kangaroo system, casualty rates during the approach phase dropped below 5%. Men who would have died crossing open ground arrived at the objective ready to fight. The tactical impact extended beyond simple casualty reduction. Infantry arriving by Kangaroo maintained unit cohesion. They weren't scattered by suppressive fire during the approach. Their section leaders could command effectively because the sections were still intact when they dismounted. The tempo of the assault increased because the dismount point could be closer to the objective than any safe assembly area for foot-mobile troops. German after-action reports from Totalize expressed consistent confusion about the Canadian tactics. They had engaged what they identified as tanks, only to have those tanks disgorge infantry in unexpected locations. Their defensive fire plans, designed for infantry advancing on foot, were ineffective against armored carriers. Some reports describe attempts to target the Kangaroos with anti-tank weapons, but those weapons were needed against the actual gun tanks supporting the assault. The innovation spread immediately. British units requested Kangaroo conversions for their own infantry. By September 1944, the conversion program expanded to include Sherman tanks, rendered obsolete by battle damage or mechanical failure. The concept had proven itself so thoroughly that any available armored hull was considered worth converting. The operational employment evolved rapidly through practical experience. Early doctrine called for dismounting at 200 to 300 meters. Combat experience pushed that distance closer, sometimes to within 100 meters of enemy positions. Crews experimented with suppressive fire from the carrier itself, mounting machine guns to provide covering fire during the dismount. The simple idea of armored infantry delivery generated tactical refinements that wouldn't be formally codified until years later. By the end of the Northwest Europe campaign, the Kangaroo was integral to Canadian and British assault doctrine. Any attack against prepared positions included Kangaroo-mounted infantry as a standard component. The vehicles that had failed as gun tanks had become indispensable as personnel carriers. The Kangaroo's immediate legacy was survival. Thousands of Canadian and British infantrymen lived through assaults they likely would not have survived on foot. That alone justified the concept. But the doctrinal impact extended far beyond the Second World War. The United States Army studied the Kangaroo operations extensively in post-war analysis. Their conclusion was unambiguous. Armored infantry delivery represented a fundamental evolution in combined arms tactics. This analysis directly influenced the development of the M75 and later the M113 armored personnel carrier, vehicles that became the backbone of American mechanized infantry doctrine. The British continued Kangaroo operations into the immediate post-war period and incorporated the lessons into their own armored personnel carrier development. The FV-432, introduced in the 1960s, was a direct descendant of the battlefield improvisation that Simonds had ordered in Normandy. The modern infantry fighting vehicle, whether it's the American Bradley, the Canadian LAV, or any of dozens of contemporary designs, owes its doctrinal foundation to the Kangaroo concept. The idea that infantry should arrive at the objective in armored protection, that they should dismount from vehicles rather than walk into fire, that mobility and protection are as important for infantry as firepower. All of this traces back to converted ram tanks in 1944. As for the ram itself, the verdict requires separating intention from outcome. As a gun tank, it failed. The turret ring limitation was a design flaw that couldn't be corrected, and the battlefield moved beyond its capabilities before it could deploy. But that failure was the product of impossible timelines and evolving requirements, not incompetent engineering. As an innovation platform, the RAM succeeded beyond any reasonable expectation. The cast hull technology pioneered at Montreal Locomotive Works influenced post-war Canadian armored vehicle production. The industrial capacity created to build the RAM supported continued military manufacturing, and the vehicle itself, repurposed from its original role, became the template for a tactical revolution. The RAM demonstrated something fundamental about Canadian military innovation. When conventional solutions were inadequate, Canadian engineers and commanders looked for unconventional answers. When a gun tank couldn't fight as a gun tank, they found another way to make it valuable. That flexibility, that willingness to abandon failed approaches and pursue functional alternatives, characterized Canadian operations throughout the war. 570 RAM tanks, 0 combat deployments as gun tanks, uncounted infantry lives saved by their conversion to Kangaroos. A doctrinal legacy that shaped mechanized warfare for the next 80 years. By the only metrics that matter in war, mission accomplishment and lives preserved, the RAM was a success. just not the success anyone planned when production began. The forgotten war machine wasn't forgotten because it failed. It was forgotten because it succeeded at something other than what it was designed to do. And in that success, it proved more influential than most vehicles that fought exactly as intended.